Okay, radiation damage. Acute damage comes from exposure to large amounts of radiation in a short period of time. Main sources of this would be nuclear bombs and exposed nuclear reactor cores, so nuclear accidents. In this process, a large number of cells die, especially those in the immune system and the intestinal lining. Symptoms would be a weakened immune system, an inability to absorb nutrients. So a mild case, it's possible to recover from, but in more extreme cases, death is usually due to infection that your body can no longer defend itself against. Lower doses over longer periods of time would be a more chronic exposure that can cause an increase in cancer risk. Radiation can damage your DNA. Sometimes affected cells will be killed, but other times affected cells can grow abnormally and become cancerous. And cancerous is a type of cell that's growing out of control. And so that causes issues with the other organs in your body. Cancer risk does increase with increasing radiation exposure, but we don't know what the exact threshold is. Nobody's willing to volunteer for tests on this. Go figure. Radiation could cause genetic defects in future generations. If the DNA in the eggs or sperm are damaged by radiation, the offspring could have genetic abnormalities. We've observed this in laboratory animals, but it has not been verified in humans, not even in studies of Hiroshima survivors. So survivors of the bombs on Hiroshima have been studied, and there is no evidence of genetic defects in their offspring, but it has been observed in laboratory animals. So measuring radiation exposure, to measure something you have to have a unit. There are a lot of different units for radiation exposure because it turns out it's kind of a difficult thing to measure. You can measure exposure as the number of decay events to which an individual has been exposed. So a Curie is 3.7 times 10 to the 10th decay events per second. A Röntgen is another unit, 2.58 times 10 to the minus 5 coulombs of charge per kilogram of air. Those aren't very useful because they don't really give us any information about what type of exposure that was or how harmful it was. So we often report human radiation exposure in REMS, Röntgen Equivalent Man. It's a weighted measure of radiation exposure, accounting for different ionizing power of the different types of radiation. If you're exposed to alpha decay, alpha radiation, or gamma radiation, the same amount is going to do a different amount of damage. And so Röntgen Equivalent Man accounts for that. So we are being exposed to radiation. On average, a normal person will be exposed to about 1/3 of a REM in a given year. Most of that comes from natural sources, especially radon. I grew up in the Midwest where people have basements, and there's naturally occurring uranium in the soil, and one of the products of that decay is radon gas. So radon gas seeps into people's basements. You go down the basement, you breathe the air, you get radon in your lungs, and so that's not good. So in addition to like carbon monoxide detectors, people also have radon detectors in their basement to alert them if their basements have radon. So that's a big source. Consumer products, medical sources, x-rays, nuclear medicine, testing, that sort of thing. And then, consumer products is this tiny orange one here. Cosmic terrestrial internal radiation is at 27%. So the internal radiation would include the carbon-14 that that came from the plants that you've eaten or the animals. So consumer products and other sources about only 3%. What are the effects of radiation exposure? Well, it takes a lot more than the natural amount to produce measurable health effects. The first measurable effect would be a decreased white blood cell count, and that would happen at an instantaneous exposure of about 20 rem. So this table gives probable outcomes based on the amount. This would be an acute radiation exposure. So 100 to 400 rems in a short period of time would radiation sickness, skin lesions, increasing cancer risk. 500 would probably kill you.